Imagine a multi-million product Magento store running perfectly optimized front-end code, yet it still grinds to an absolute halt. When a site slows down, the immediate instinct is to look at the surface. We compress images, defer JavaScript, and obsess over rendering times. But for enterprise catalogs, this is looking in the wrong place. The symptoms of a truly strained system rarely show up as a single consistent error. One day the storefront drags. The next, checkout conversions drop due to session instability, or a routine background job silently stalls out. These are not front-end issues. They are symptoms of back-end resource contention. The storefront suffers because customer requests are forced into a bottleneck. They have to fight for the exact same server memory and CPU cycles as massive, invisible back-end operations. Every time a shopper loads a category page, it might collide with inventory syncs, heavy catalog reindexes, or complex third-party ERP pulls. True scalability requires shifting our perspective. We have to stop treating performance as a front-end speed metric and approach it as an engineering challenge of back-end workload distribution. The core flaw is the monolithic bottleneck. Uncached requests, API calls, and background tasks slam the main application server simultaneously. Surging traffic instantly consumes available PHP workers. When a heavy catalog index triggers alongside this, it pushes the system past its hardware limits. With the database locked up handling the catalog, transactional queries are forced to wait. This creates deadlocks, directly breaking critical order creation and invoicing workflows. If you allow every process to fight for the exact same core processing power, the storefront will inevitably collapse under its own operational weight. To fix this, we have to change the rules of engagement. The primary architectural directive is to intercept and handle requests at the highest possible layer, long before they ever reach the Magento core. We start at the perimeter. The Cloudflare Edge Cache instantly absorbs static content requests globally. What gets past hits the Varnish full-page cache, serving pre-rendered HTML so application nodes never execute PHP. By the time the traffic filters through, only the highly dynamic, uncached requests, like active checkouts or personalized data, are allowed to proceed. To support these remaining requests, a localized Redis backend cache handles internal data transfer. This drastically reduces network pressure between the application and the database. Compare this to the monolithic baseline. Instead of a single server fighting thousands of simultaneous connections, the origin server now only processes a fraction. Think of a robust caching architecture as an intercept strategy, a system designed specifically to protect the origin server from having to work at all. Deflecting traffic solves load, but it does not solve continuity. A fast site means nothing if a customer loses their cart right in the middle of a high-traffic search. Standard file-based session storage leaves stores vulnerable. When application nodes get busy writing to disk, sessions drop. This creates unexpected logouts and severe cart inconsistencies, exactly when buying intent is highest. To solve this, enterprise environments require decoupling session data entirely using Redis Sentinel. Moving active sessions out of the local file system and into a dedicated memory instance isolates them. Even if the main application nodes are struggling under a traffic spike, the session data remains fully intact and instantly accessible. This setup introduces crucial failover redundancy. If the primary cache server goes down, a secondary node automatically takes over. The customer never notices a glitch. This stability becomes critical during peak promotional campaigns or when massive third-party data syncs hit the system. Decoupling session state directly translates to reliable checkouts. In enterprise commerce, protecting the session is protecting the revenue. With the storefront and user sessions protected, we have to look at the heaviest internal burden a Magento store carries: large product catalog operations and indexing. Processing updates for millions of products in single, oversized batches demands massive amounts of RAM. This intense memory pressure inevitably bleeds over, choking the resources needed for dynamic page routing, slowing down the storefront, and delaying active customer orders. The architectural solution is fragmentation. We break the monolithic indexing workload down into smaller, strictly controlled batch sizes. Then we use multi-threading to process these scoped indexes in parallel, maximizing efficiency without causing sudden spikes in resource utilization. This granular control keeps the resource consumption flat and predictable, regardless of whether you are updating 50 products or 500,000. Predictable catalog indexing acts as a firewall. It guarantees that intense backend data management can never disrupt the active storefront experience. There is one final hidden bottleneck to resolve: Magento's reliance on background jobs for inventory synchronization and queue processing. Standard setups use timing-based cron executions. When these schedules miss or overlap, they create massive queue jams, leading to cascading delays in critical store operations. To overhaul this, we implement the supervisor daemon. Instead of waiting for rigid scheduled triggers, supervisor allows queue consumers to run continuously in the background, processing data exactly as it arrives. It also provides auto recovery. If a worker process fails, supervisor automatically restarts it. There is no waiting for manual developer intervention to clear a stalled queue. Replacing rigid cron schedules with intelligent, self-healing daemons removes the risk of a single jammed process bringing down the store's entire operational workflow. Consider the previous scenario: a concurrent traffic spike, a massive catalog update, and heavy backend syncing, all running simultaneously without disruption. Now, the newly implemented edge and varnish layers immediately absorb the traffic surge, keeping the origin server completely quiet. The batched indexing safely processes the catalog changes in parallel, while supervisor effortlessly handles the background synchronization. The core Magento application remains perfectly stable, completely protected by its surrounding microinfrastructure. The store has evolved from a vulnerable monolithic bottleneck into a horizontally and vertically decoupled data pipeline. Real Magento optimization requires moving beyond surface-level fixes to address the underlying infrastructure. If your enterprise storefront is experiencing hidden back-end bottlenecks despite extensive front-end optimizations, it is time to rigorously audit your infrastructure layers. Scalability at this level rests on engineering and architecture where the core application is systematically asked to do less.